Welcome. In this video, we are going to look at factoring trinomials when your a value is not 1. So if you have more than one x squared, like 2x squared, 6x squared. So we did a lot of these with our algebra tiles, and you can use that method, although it requires a lot of kind of guessing and checking, which is acceptable. But we're going to look at what are some strategies we could use to make it a little easier to systematically attack these problems. So if we're looking at a trinomial, the first thing we're always going to do is factor out our greatest common factor if possible. So sometimes you'll do that, and then you'll end up with a trinomial that has an a value of 1, and then you can use our strategies from that to continue factoring. If you don't, then you're going to find a times c. And so we're looking at our lead coefficient and your constant, multiplying those together, and find factors of a times c that add up to b. So we're really looking at where do those four numbers come from, right? So if we're going to end up with our area model, right? If I have something here and here and here and here, right? When we multiply those things together, these two are going to end up being in this factor, and these two are going to be end up in this factor, and this is going to be my a and c. So when we multiply those two things together, we're going to end up with all four of your coefficients from your two binomials. So if we take 2 times 21 here, that's our a times c. So a times c equals 2 times 21. So that's just getting all of our factors of our coefficients together. So I have 42. Now we're looking for factors of 42 that add to be 17. So things of 42 that add to be 17. So I'm just going to start listing factor pairs of 42. I know they're both positive because it's positive, positive. So 1 and 42 doesn't work. 2 and 21 doesn't work. 3 and 14. Oh, that works. Okay. So that is our factor pair there. So once we have that, we're going to rewrite this middle term using those numbers. So that's why they have to add to be that. So now I have 2x squared. I'm going to have this exact same thing, but I'm going to rewrite this middle term as these two. And it does not matter which order you put them in, you're still going to end up with the same thing. So if I put 3x plus 14x plus 21. So this is exactly equal. We just found that special pair that relate those four factors into these two terms. So we split that into two terms. Why that helps us is now we have four terms, and if you have four terms, you can do greatest common factor and grouping. So if we have those two and those two, then we're going to look for our greatest common factor. These first two is just x. And then plus greatest common factor here is 7. Okay, so we did our greatest common factor once. Now, just like our four terms, we're going to do greatest common factor again. So these two big terms, we're looking at what do they have in common. They both have this 2x plus 3. So we pull out at 2x plus 3, and then we're left with an x plus 7. Okay, so really this first part is our only difference is we're figuring out how do we split that into four terms to then do our greatest common factor twice from there. Okay, so look for greatest common factor first, 6, 11, 4. Don't have a common factor aside from 1. So then your next step is multiply a times c. 6 times 4 is 24. So I'm looking at factors of 24 that add to be 11. So 1 and 24 doesn't work. 2 and 12 doesn't work. They're both positive because we have positive, positive. 3 and 8. Oh, that works. So now I'm going to rewrite 11x. Everything stays the same. But 11x, I'm going to rewrite as 3x plus 8x plus 4. So we just took that middle term and rewrote it using those factors of a times c that add up to be that b value. Okay, once we do that, now we have four terms, so we can group. Greatest common factor here is 3x. When we divide that out, we get 2x plus 1. Greatest common factor here is 4. Don't forget that plus. This is a separate term. And then we have 2x plus 1. Really, we want those two things to match. So once they do, then we can factor out the 2x plus 1 itself. And we're left with 3x plus 4. Okay, check and make sure. Can we factor either of those further? No greatest common factors, so we didn't miss that along the way. Okay, let's try a couple more. So remember, greatest common factor first. 3, 16, 16. Nope. So then we're going to multiply 3 times 16. Oh, 3 times 16 is 30. 3 times 6 is 18, 48. So we're looking for factors of 48 that add to be negative 16. So they multiply to be positive, add to be negative. They're both negative. So -1, -48 doesn't work. -2, -24 doesn't work. -3, -16 doesn't work. -4, -12. Ooh, that one works. And once we find our factor pair that works, we're just rewriting this middle term as two terms. So 3x squared is still 3x squared minus 4x minus 12x plus 16. So we still should be equivalent to what we started with. Then we're grouping. So what do those two have in common? X. We're left with 3x minus 4. What do those two have in common? Oh, be careful here. I want it to end up to be 3x minus 4. So since this is negative 12x plus 16, I'm going to factor out a negative 4. And I get 3x minus 4 so that those two match. So we can play around with our negatives there just like we have before. Okay, now those both have a 3x minus 4, and we're left with an x minus 4. Just check to make sure we can't factor any further. We only have two terms, so we're looking for greatest common factor or a difference of squares. We don't have either of those, so we're ready to move on. Okay, greatest common factor for 15 is 1. Multiply 4 times 4, negative 16. So they multiply by negative, so one's negative, one's positive. They add to be a negative, so the bigger one's negative. 1 and negative 16. Oh, works right off the bat. Okay, so let's use that pair then and rewrite 4x squared plus x minus 16x minus 4. Once we have four terms, we can group. Greatest common factor is x, 4x plus 1. Don't forget that 1. Okay, again, I want this one to look like this one. So this is negative 16x minus 4. I'm going to take out a negative 4 to get 4x plus 1 as well. Once we're there, they both have a 4x plus 1, and we're left with x minus 4. Okay, hopefully you're getting pretty good at this. If you want to try some on your own and come back check your answers, that's great. Not keep following along. So greatest common factor, 6, 17, 12. Not really one there, but they are all negative. So you can choose to leave that negative in there or to take the negative out right away. Sometimes it's easier to think about your numbers if you pull out a -1 first. It just makes your numbers a little less complicated when you're going through them. Okay, so that -1 we'll just take with us along the way. We're multiplying the whole thing times the -1. Multiply a times c, so 6 times 12, that's what, 60, 72. And then we're looking for factors of 72 that add to be 17. So for plus plus, they're both positive, so 1 and 72 doesn't work, 2 and 35, 36. 3 and 24, 4, 6, 3 and 18. 5 doesn't go into 72. 6 and 12. Does that work? No, that doesn't work. Is that right? 7 doesn't go into 72. 8 and 9. That's our factor pair right there. Okay, so just keep going until you find the one that works. See right off the bat, you don't have to do that systematically, but works well to work through if you are stuck. So now we're going to leave that -1 out here. Say this is 6x squared plus 8x plus 9x plus 12. Then do our greatest common factors here. So 6x squared and 8x, 2x goes into both of them, 3x times and 4 times. 3 goes into both of those, 3x and 4. Good, they match. Don't forget we still have this -1 out front. Okay, both of these things have a 3x plus 4, and we're left with a 2x plus 3, that -1 out front. Okay, this is an acceptable answer. If you got negative 3x minus 4 times 2x plus 3, that would be acceptable. Negative 2x minus 3 times 3x plus 4, also acceptable. So you don't have to factor out that negative 1. It just makes your process a little easier thinking about your positives and negatives along the way. Okay, let's try another one here. We have 3x squared plus 11x minus 4. Greatest common factor is 1. So we're going to do a times c. I get negative 12. So we multiply to be negative, add to be a positive. One's negative, one's positive. The bigger one's positive. Negative 1 and positive 12, right there off the bat. 3x squared minus x plus 12x minus 4. Okay, greatest common factor here is x. 3x minus 1. Greatest common factor here is 4. And 3x minus 1. Greatest common factor here is 3x minus 1, and we're left with x plus 4. Okay, hopefully these are coming a little easier. If you're good to go, try these next two on your own and then come back to check your answers. Okay, a times c, negative 5 times negative 1 is positive 5, and add to be positive 6 is 1 and 5. Negative 5x squared plus 5x plus x minus 1. Okay, greatest common factor here is 5. Up to you if you want to take a 5 or a negative 5. I'm going to take a 5 out, and then 5x. I get negative x plus 1. Ooh, that looks really close to this. We need to take out a negative 1 to get that to look the same. Now both of those have a negative x plus 1, and this guy has 5x minus 1 left over. Okay, so keep in mind if your signs are flip-flopped, you could still be right because we could factor out a negative 1 from that whole thing as well. Okay, last one, greatest common factor, nope. Multiply negative 6, factors of negative 6 that add to be negative 1. One's negative, one's positive, they add to be negative 1, so negative 3 and 2. Negative 3x squared minus 3x plus 2x plus 2. Once we have 4 terms, group. Factors there, we're looking at negative 3x, x plus 1. Here we're going to pull out a 2x plus 1. Greatest common factor here is x plus 1, and we're left with negative 3x plus 2. Okay, can't factor either of those further, so we are all done. Okay, that is all I have for you. Remember, your process here is look for greatest common factor if possible, multiply a times c, then you're looking for factors of that number that add up to be b, rewrite with 4 terms, and then we're to a tool we already have that factor by grouping. Okay, that is all I have. Thanks so much for watching.